All right, so we're back with another video, and we're still going to rewrite and simplify trig functions using the identities. In the previous video, we were basically just using the Pythagorean identity, reciprocals, and quotients. But now we're gonna look at examples where we have to use the cofunction identities. So now we're going to be using the cofunctions more, and it's gonna involve some factoring. But stay with me, I think you'll see it's essentially the same thing. We're just rewriting and simplifying. All right, I have my identities. All right, so let's take a look at the first problem. We have sine squared theta cosine theta minus sine pi over 2 minus theta. Right away, we know we're going to use the cofunction identity because we see this, right? Even though I didn't write them all down, they're essentially the same thing. We're using our cofunction identities because we have that piece in our problem. So that's what I'm gonna do first. I'm gonna rewrite this. This is cosine because sine and cosine are cofunctions. So this is really just sine squared theta cosine theta minus cosine theta. All right, at this point, we have to factor, right? We have one term here and another term here. What do those terms have in common? They have cosine in common. Actually, they have a negative cosine in common. So I'm going to factor out a negative cosine theta. When I do that, what's left with sine squared? It's negative sine squared theta plus 1. Right, so I factor out negative cosine becomes 1, and here we're left with negative sine squared theta. This is another way of writing the Pythagorean identity because it's 1 minus, this is like saying 1 minus 1 sine squared theta, which is cosine squared theta. So this is negative cosine theta times cosine squared theta, which is just negative cosine cubed theta. And again, we can check using Desmos. So all of this simplifies to this. The key things here is knowing that this is cofunction. So we had to rewrite it as cosine. We factored it out. Recognizing that negative sine squared theta plus 1 is really 1 minus sine squared theta, which using the Pythagorean identity, it's cosine squared theta. Multiply, we get negative cosine to the third theta. Okay. What else? So let's try one more. We're gonna start with cosecant pi over 2 minus theta minus tan squared theta secant theta. So different, we're not using cosine and sine anymore, but we're still using the cofunction. Cosecant of pi minus 2 over theta. Well, cosecant and secant are cofunctions. So this is really just secant theta minus tan squared theta secant theta. All right, so we got a factor. Remember, we have one term here and one term here. What do they have in common? Secant. So we're going to pull out negative secant theta, and we have negative 1 plus oh, my bad. These are all negative. So we're going to pull out negative secant theta, and we get a positive 1 plus tangent squared theta. How does that help us? Well, let's recognize that this is really tangent squared theta plus 1, which is this identity. So it's secant squared. right? Tangent squared theta plus 1 is secant squared theta. So we get negative secant theta times secant squared theta, which is just negative secant to the third theta. And again, we can check using our Desmos. So we start with our whole thing. We recognize that this is our cofunction, so we get negative secant theta. We factor out the negative secant theta, and we get 1 plus tan squared theta. Recognizing that this is really just tan squared plus 1, which is secant squared. And then we multiply and we get negative secant to the third power of theta. So we took two types of, we use all of our identities, the cofunction, the Pythagorean, and our reciprocals, in order to rewrite our functions. Awesome. Where to next? What if we wanted to subtract sine and cosine? It's essentially going to be everything that we've been doing using our identities. So let's look at an example. So sine x, cosine x, all over 1 minus sine x, minus 1 plus sine x, all over cosine x. Don't get confused that we're using x instead of theta. The book likes to switch it up on us. All right, we are subtracting. In order to subtract, we have to have common denominators. We do not have common denominators, but one way to get common denominators is to multiply this side by 1 minus sine x over 1 minus sine x, and to multiply this side by cosine x over cosine x. All right, so we do our distributive property, and we get sine x times cosine squared x all over cosine x minus sine x cosine x minus, so here we have to multiply, but it's differences, so there's going to be no middle term, so it's 1 minus sine squared x all over the same thing, cosine x minus sine x cosine x. All right, so I can now rewrite this as sine x cosine squared x minus cosine squared x. I can do that because of the Pythagorean identity. 1 minus sine squared x is cosine squared x. So why would I write something that's two things where I could just rewrite it as 1 all over cosine x minus sine x cosine x. Remember, because when we're subtracting, we just rewrite it over one denominator. All right, so we have multiple terms here, but we have like things that we can factor. In this numerator, we can factor out the cosine squared x. And here we can factor out a negative cosine. All right, so if I factor out that cosine squared x, I'm left with sine x minus 1. And if I factor out a negative cosine x here, I'm left with a negative 1 plus sine x, which we can rewrite that, and we get cosine squared x sine x minus 1 over negative cosine x sine x minus 1. What cancels? Well, That cancels. This little 2 cancels, the cosine cancels, and you're left with negative cosine of x. So what did we do? Let's go back. We first got common denominators by multiplying by the opposites. We multiplied here. Recognize that 1 minus sine squared x is really cosine squared x. And it gave us this. Once you're here, you see a bunch of functions and you're like, let me factor out what's alike on the numerator and factor out what's alike on the denominator. When I do that, I'm left with cosine squared x, sine x minus 1. The idea here is we want stuff to cancel. So when I factor out the negative cosine of x, I get negative 1 plus sine x, which is really the same thing. They cancel. This becomes just cosine. That cosine leaves us, and we're left with negative cosine of x. All right, so let's say we have cosine x over 1 plus sine x plus 1 plus sine x over cosine x. All right, while we're adding, you still need common denominators. So this one, we're going to multiply by this denominator. And this fraction, we're going to multiply by this denominator. Well, that gives us cosine squared x over cosine x plus sine x cosine x plus, we have to use the distributive property. 1 times 1 is 1. 1 times sine x is sine x. Sine x times 1 is sine x, so I get 2 sine x plus sine squared x all over cosine x plus sine x cosine x. All right, I can rewrite this and I get 1 plus 2 sine x plus sine squared x plus cosine squared x all over the denominator. This step is important because in this step, we now see we have sine squared and cosine squared together. That is our Pythagorean identity, and they equal 1. 1 and 1 is 2. So we're left with 2 plus 2 sine x all over cosine x plus sine x cosine x. Let me go through that again. So we rewrote the numerator, and sine squared x plus cosine squared x is really 1. 1 and 1 is 2. So the numerator simplifies to 2 plus 2 sine x over cosine x plus sine x of cosine x. What we realize here at this point, if we can't use the identities anymore, if there's no more Pythagorean identity, if there's no more reciprocal or cofunction, then at this point we're looking to factor. What is the same in the numerator in both terms, and what is the same in the denominator in both terms? Well, the numerator, I can pull out that 2, and I'm left with 1 plus sine x. That is telling me that I'm trying to get 1 plus sine x in the denominator as well. I can factor out the cosine x, and I get 1 plus sine x. They cancel, and this all equals 2 over cosine of x. So again, just like simplifying, there's only just one more step, and the first step is to make sure you get common denominators so you can add or subtract. But once you do that, you're just, again, using those identities to simplify tangent and cotangent. Or excuse me, to simplify all the trig functions. All right, there is one more. and it's probably the most simple one. And it is saying if you have 1 over 1 plus cosine of x. They don't like you having this 1 over 1 plus cosine of x, right? They want you to rationalize the denominator or make it so that the trig function is not in the denominator. To do that, you have to multiply by the conjugate. And the conjugate is just a fancy way of saying we flip the sign. So it's 1 minus cosine of x in this case. We do that because it cancels out the trig function. So we have 1 over 1 plus cosine of x, and we just have to multiply the numerator by 1 minus cosine of x and the denominator of 1 minus cosine of x. Well, what happens when you get that? You get 1 minus cosine of x all over 1 minus cosine squared of x. Well, here we have, now we have to check for identities. What identity is that? That's the Pythagorean identity. So I have 1 minus cosine of x over sine squared of x, which is really just 1 over sine squared x minus cosine x over sine squared x. So just like you can put subtraction together, you can also break it apart. So I have 1 over sine squared x minus cosine over sine squared x. Well, I can rewrite this even more. 1 over sine squared of x minus cosine of x over sine of x times 1 over sine of x. So again, we're just rewriting even more. And now we're going to use our properties. Well, sine squared's reciprocal is cosecant. So this is really just cosecant squared of x. Cosine over sine is cotangent of x. And 1 over sine is cosecant of x. So this is our final answer. So now we don't have any fractions and the trig functions are in the denominator. But when you start with having a trig function in the denominator, you just have to multiply by the conjugate, which is the opposite sign. So we do this, and we just have to use our algebra skills to break it apart. So this is where I know we're going to get tripped up. But if I have subtraction over a common denominator, I can break it up. I have 1 over sine squared x minus cosine x over sine squared x. I can break apart the sine x's, and it's cosine over sine, 1 over sine. And now I use my reciprocal rules. I know that this is cosecant, cotangent, and cosecant. All right, my friends. So ultimately, our learning target was to be able to rewrite and simplify trig functions. And I showed you a bunch of different examples on how to do some. Sometimes when we have to add and subtract. So the first video was just the basic rewriting. Then at the beginning of this video, we learned how to add and subtract. And then at the bottom, and this last one, we learned how to rationalize the denominator by getting the trig function out of the denominator by multiplying by the conjugate. But there you have it. So this whole video, we reviewed everything that we did beforehand, and then we learned something new, and then you'll have your problem set to do after this. Thanks for watching.